Okay, here we go with the second example. This is actually not an example from the text anymore. It's an example from an earlier version of the text, but it's on a worksheet. It's good things to know about. One of the applications of parabolas of quadratics is gravity. Both the gravity that keeps things floating to the Earth here on the planet and the thing that keeps the Earth rotating around the sun. So we have a general formula for gravity. The general formula, H equals -1/2 gt squared plus v sub 0 t plus h sub 0. It's a lot of letters here, a lot of variables going on. Want to make sure you can handle those. H is the height after t seconds. G is gravity, and the acceleration due to gravity is either 9.8 meters per second squared or 32 feet per second squared, and so that you have to be sure whether you're using the right units. If you're in meters, work with meters. If you're in feet, work with feet. V sub 0 is an initial upward velocity. H sub 0 is the initial height. So we've got this information now. A ball thrown upward from an initial height of 4 feet, with an initial velocity of 59 feet per second. So the equation for the height of the ball after t seconds, using this formula, h equals -1/2. G is gravity. We are in feet, so we're going to use 32 feet per second squared. T squared, the initial velocity was 59. And the initial height is 4 feet. So we're working on this. We need a calculator here. We'll find out some of these values here for the table. Simple enough to get these values going. Y equals. Under y equals, we need to use x and y instead of h and t. So I've got y equals -1/2 of 32 is 16. I'm just going to change it to 16x squared plus 59x plus 4. I've got that graph. Got that. Looking on a table now, I can find out all of these different heights. I have to type things in better. At time equals 0, the ball is at 4 feet. At time equals 1, it's at 47 feet. At 2 seconds, 58 feet. At 3 seconds, 37 feet. And at 4 seconds, -16 feet. So let's do that. 4, 47, 58, 37, and -16. We can draw a graph of this as well. It looks like it goes up to a height of 58 feet, and it also looks like after 4 seconds it's below the ground. So the only times I'm interested in go to about 4 seconds. I'm going to go -1 to 4 so I can see the axis. On the y-axis, I need to get to at least 58 feet. 60 is probably better. I'm going to go all the way to 70 just to be sure that I get it, and I'm going to count by tens. So here is a graph of what's going on. There's the height of the ball. Good picture there. What is the maximum height that the ball reaches, and when does it reach that height? Well, the maximum, you can see, is the vertex, and the quick way to find the vertex is under F5 Math. You've used F5 for intersections before. Now we're going to find a maximum. This parabola has a maximum because it opens down. The lower bound is on the left, like usual. The lower on the left, the upper bound on the right, and it will tell us the maximum. The maximum height is about 58.4 feet, and it happens at about 1.84 seconds. So let's put that on the graph. 1.84 seconds and 58.4 feet. So the maximum height the ball reaches is there. Ball reaches a maximum height of 58.4 feet after 1.84 seconds. And the last question now, when does the ball hit the ground? Graphically, you can see that here. Here's the ball hitting the ground. We can tell from the table that it's someplace between 3 and 4 seconds, because at 3 seconds the height is positive, at 4 seconds the height is negative, meaning it's already gone past the ground level. And so we've got there. In order to find that graphically with the calculator, instead of doing maximum or minimum, what we're looking for is the place where it's 0. And so under F5, we're looking for the place where it's 0. That's the second choice. F5, 0. And the point we're looking for is down here. Again, lower bound to the left. I'm to the left of the point now. You have to think left, right, not up, down. So the lower bound is to the left, and the upper bound is to the right. And it is 0 at 3.75 seconds. So 3.75 and 0. There we have it. So the ball hits the ground 3.75 seconds after it was thrown, 3 and 75/100ths. That's a long example, but it's going through several key ideas. I think you'll be good.